Hey fam, welcome to Driven Math and Physics. So today we're going to continue looking at Archimedes principle questions. So the question that we have here says a metal cylinder of density 8,200 kgs per cubic meter. So the density of the cylinder is equal to 8,200 kg per cubic meter. And they're saying the height of the cylinder is equal to 12 centimeters. It's hanging freely from a string and is half immersed in a fluid of density 1000 kgs per cubic meter. So the density of the fluid is equal to 1000. That's water, people, water. Okay, now it's hanging halfway. Okay, it's immersed halfway, it's half immersed. So they want us to find the volume of the immersed part. Okay, and then we need to find the earth thrust of the cylinder and determine the tension in the string. This is going to be fun. Now, there's a detail here that is missing that is very important. That detail is the radius of the cross-section of the cylinder. So let's say the radius is 4 centimeters. Okay, the radius is 4 centimeters. It means the height is also 0.12 meters. The radius will be 0.04 meters. Okay, now from there, if that is just conversion from centimeters to meters, let's calculate the volume now. So the volume of the immersed part, volume immersed, will be equal to half the volume of the cylinder. It's half immersed, people. I think that makes sense. So it will be equal to pi r squared h. Okay, so from there it will be times half. Sorry about this. So it will be pi multiplied by 0.04 squared multiplied by 0.12 times 1 over 2. So when we try to actually find the answer to this, let me just take out my calculator. And so if we try to start punching in, it will be pi multiplied by 0.04 squared multiplied by 0.12 times 0.5. That gives us 0.001206. This one is our volume in cubic meters. Okay, now from there, once we have found the volume that is immersed, that means it's half the total volume of the cylinder. Once we have found that volume, they're telling us here to find the earth thrust on the cylinder. So to find the earth thrust on the cylinder, earth thrust is equal to weight of fluid displaced. Okay, now that will be density of fluid times volume of fluid displaced times what? Gravitational field strength. Okay, now the volume of the fluid displaced will be equal to the volume of the object immersed. Okay, that means we take our density, the liquid is water, so 1000 multiplied by the volume immersed of the object is the volume of the liquid displaced. That's 0.001206 cubic meters. Okay, and then from there we multiply by the gravitational field strength, like that. So from here, what we end up getting as the earth thrust is equal to then we multiply 1000, we multiply 10, we get 12.064 newtons. Okay, so that's our earth thrust. And then part C, they want us to determine the tension in the string. That means that is the weight of the block when it is immersed. Okay, so we know that weight of the cylinder in the liquid, maybe in the fluid, will be equal to weight of the cylinder in air minus earth thrust. Okay, we know this from the earth thrust formula. All right, now do we know the weight of the cylinder in air? What we have been given is the density, and we can find the volume. So before we do anything else, let's do that. Let's find the weight in air. Okay, so we know that the density of the cylinder is 8,200. Okay, so that's 8,200 And we know that the volume of the cylinder is equal to 2 times 0.00001206, like that. What we get, 2 times 0.001206, we get 0.002412 cubic meters. Okay, so from there we can calculate the mass as density times volume of the cylinder. So that will be 8,200 multiplied by 0.002412 cubic meters. What we end up getting is 8,200. We get 19.7784 kg. So we've calculated the mass. From the mass, let us find weight. Weight is equal to mass over G. Okay. No, wait a sec. What am I doing? Oh my God. So that is, we want to find weight, which is mg. My apologies for that. So that will be 19.7784 kgs multiplied by 10 newtons per kgs. What you get is 197.784 newtons. That's the weight in air. Okay, after we found the weight in air, now we can go back to our formula now. This will give us 197.784 newtons minus 12.06 as the air thrust. And what we end up getting, is, we end up getting 185.72 newtons. That should be our answer. That one will be the tension in the string. Wow, long process. But yeah, can you try to do it and see if you can find the answer yourself? Otherwise, this is how you do this problem. Thank you.